Ever catch yourself uh, scrolling through apps or playing a video game, and you just stop and think like, how does all this stuff actually work?
Yeah,
Well, that's what this deep dive is all about.
exactly.
We're going to be tackling computer engineering,
Yeah,
basically everything that powers the technology that we rely on every day.
absolutely. And the really fascinating thing is it's not just about like the code or
Yeah.
the hardware. It's really about how people and computers solve problems together.
Okay.
And that story, that goes way, way back.
Way back. Okay, so where do we even begin?
Centuries ago.
Wow, really? Centuries?
Yeah, we're talking like,
abacus old school.
that's exactly right.
Wow.
The abacus around 2400 BC
Okay.
might seem a world away from your smartphone,
Right.
but it represents that same human desire to make sense of numbers.
I like it. Okay, so we've gone from counting beads to Silicon Valley.
Yeah.
How did that happen?
Well, fast forward a little bit
Okay.
to the 19th century. This guy, Charles Babbage, he was a real visionary. He came up with this idea for a mechanical computer
Okay.
called the analytical engine.
Uh-huh.
And this thing, it had features that we still consider essential today.
Really?
Yeah, like an arithmetic logic unit for
Mhm.
doing calculations, a control unit to kind of make decisions,
Right.
and even integrated memory.
Wow. That's so ahead of its time.
Way ahead of its time.
But he was really thinking about this stuff even though
Yeah.
the technology wasn't quite there yet.
Exactly. But unfortunately,
Yeah.
the analytical engine was never actually built.
Really?
It was just too complex for the time.
Wow.
But his ideas,
Mhm.
his designs, they were revolutionary.
Okay.
They planted the seeds for everything that came after.
So it was really the invention of the transistor then.
The transistor was huge.
Yeah.
I mean, we have to mention the Atanasoff-Berry computer in the 1930s. First electronic digital computer, used binary representation and electronic switching.
Okay.
But it was really the transistor in 1947 that changed everything.
Okay.
It's hard to overstate how big of a deal that was.
I can imagine going from like those massive computers that took up
Oh, yeah.
entire rooms to something that could fit on a tiny chip.
Exactly.
That's incredible.
Made computers smaller, faster, more reliable,
Yeah.
more affordable.
Okay, so that was really the key.
Absolutely. Paved the way for everything we have today.
And then came Moore's Law, which doesn't really sound like a lot to me.
It's more like a self-fulfilling prophecy.
Really?
Yeah.
Right.
Gordon Moore, one of the founders of Intel,
Right.
he predicted back in 1965
Okay.
that the number of transistors you could fit on a chip would double about every 2 years.
Okay.
And that's basically been true.
Wow.
It's the reason why we have so much computing power
Right.
in our pockets today.
So thanks to these tiny transistors and this prediction,
Yep.
we got the personal computer. Were the Apple II and the IBM PC as revolutionary as everyone says they were?
They were game changers.
Really?
The Apple II,
Yeah.
with its user-friendly design, color graphics,
Yeah.
it made computers accessible to a much wider audience.
Okay.
And then IBM's decision
Yeah.
to use an open architecture for their PC
Okay.
meant that anyone could develop software and peripherals for it.
Oh, wow.
Yeah, that led to the PC boom.
That makes sense.
And it really shaped the technological landscape that we still see today.
Wow. Okay, so we've gone from counting beads to
Yeah,
pocket-sized supercomputers.
basically. And that's just the beginning.
We're just getting started. It's true, we've only just scratched the surface.
Okay.
Because today,
Yeah.
computer engineering is pushing boundaries like never before.
So where do we even go from here? I mean, we're talking apps, we're talking AI,
Yeah.
quantum computing. It sounds like we've stepped into the future.
Well, let's bring it back down to earth for a second.
Okay, and talk about software.
Yeah.
The apps on your phone. All
Yeah.
the software that we use every day.
So the people who actually make the apps.
The software engineers.
Okay.
Yeah, they're the ones building this entire digital world.
What does it actually take to do that?
Well, just like any kind of engineering, it's
Yeah.
about using your creativity, your logic
Okay.
to solve problems.
Mhm.
And in this case, it's about designing, building, maintaining the software that we all rely on.
Okay, so when we're talking about software engineering, we're talking about those coding languages.
Exactly.
Like C++.
C++, Java, Python.
Yeah, those sound pretty intimidating.
There's a lot to learn.
Yeah.
But at the end of the day,
Yeah.
they're just tools.
Okay.
What makes a great software engineer
Yeah.
is the ability to think creatively,
Well.
break down complex problems, and work well with others.
Okay, so it's really a collaborative effort.
It's a team sport.
Got it. So it's not just people coding alone in a basement somewhere.
Not anymore.
Okay.
These days, it's all about agile development.
Go.
Things like Scrum, where teams work together to deliver software quickly and efficiently.
I like it. Okay, so that's software engineering. But what about all this AI and machine learning we keep hearing about?
Right.
I mean, it's everywhere.
AI is everywhere, and it's only going to become more prevalent.
So break it down for me.
So AI stands for artificial intelligence. And it's basically about creating systems that can perform tasks that normally require human intelligence. Things like learning, problem solving, decision making.
I get it.
Machine learning is a subset of AI that focuses on enabling computers to learn from data without being explicitly programmed.
So instead of programming a computer to do like one specific task, we're teaching it to learn how to do new things.
Precisely.
That's amazing.
Imagine showing a child a bunch of pictures of cats and dogs. Help them identify the differences. Eventually, the child learns to tell them apart. Machine learning is similar. We feed these algorithms huge amounts of data, and they learn to identify patterns.
That's really cool.
And then based on those patterns, they can make predictions.
I see. So that's how my streaming service knows what I want to watch
Exactly.
before I even know.
They've learned your tastes.
Yeah, it's a little creepy, but also kind of cool.
It's definitely both, but it's not just recommendations. AI and machine learning are being used in all sorts of amazing ways.
Like what?
Self-driving cars.
Okay.
Medical diagnosis. Personalized education.
It's like we're living in the future.
The possibilities are endless.
Okay, so that's AI. But now let's talk about the really mind-blowing stuff. Quantum computing.
All right.
This has to be like the final frontier.
Quantum computing is a whole other level. We're talking about using quantum mechanics to perform calculations that are impossible for even the most powerful computers.
So are we talking Star Trek level stuff here?
Kind of. Because in the quantum world, things aren't as straightforward as they seem.
How do you mean?
Well, take superposition, for example. A particle can be in multiple states at the same time.
Wait, so it's not just 0 or 1?
Exactly. Instead of bits, quantum computers use qubits. And a qubit can be 0, 1, or both at the same time.
So they can do multiple calculations simultaneously?
Yes, and that makes them exponentially faster.
Okay, so what could we actually do with that kind of power?
The possibilities are mind-boggling. New drug discoveries, unbreakable encryption, even designing entirely new materials.
Wow, it sounds incredible.
It's revolutionary.
Okay, let's bring it back down to earth again.
Let's
talk about something a little closer to home. The Internet of Things.
Yes, the IoT.
Smart homes, wearable tech.
Exactly.
What's the deal with all that?
It's all about connecting everyday devices to the Internet, allowing them to collect and share data.
So my smart refrigerator
exactly can tell me when I'm low on milk.
Or even order it for you.
Wow.
But it goes beyond that.
Okay.
Think about fitness trackers, industrial sensors, all connected.
So we're creating this massive network of devices.
A truly interconnected world.
But what does that actually mean for us?
Well, all those connected devices generate tons of data. And that data can be used to make our lives easier.
Like how?
Think about traffic flow. Imagine if cars could communicate with each other to optimize routes.
Yeah, that would be amazing.
Or cities that could monitor energy and water usage.
So it's about making things more efficient.
Exactly.
But with all this data flying around, cybersecurity must be a huge concern.
Cybersecurity is more important now than ever before. So how do we even begin to protect ourselves?
Well, it takes a multi-layered approach. Strong passwords, encryption, fear walls, and constantly adapting.
Wow. So it's a constantly evolving field?
It's a digital arms race.
So where is all this data even stored?
That's where edge computing comes in.
Edge computing.
Instead of sending all that data to a central cloud.
Right, which can take a while.
Exactly. It's slow. It's expensive. Edge computing processes data closer to the source.
So like data from sensors.
Exactly.
On a self-driving car wouldn't have to travel all the way to a data center.
Exactly. It can be processed right there in the car.
That makes a lot of sense.
It allows for faster, more efficient decision-making.
Wow.
Especially for things like self-driving cars where every millisecond counts.
And then there are autonomous systems.
Yes.
Are we talking about machines that can think for themselves?
Well, not exactly.
Okay, good, because that's a little scary.
We're not at the robot uprising stage just yet. But we are talking about systems that can operate
Yeah.
without human intervention.
Okay, so still self-driving cars then?
Think about it.
Okay.
Self-driving cars use sensors
Right.
to perceive the world around them.
Right.
They use actuators to control their movements
Yeah.
and sophisticated algorithms to process information and make decisions.
Without any human input.
It's incredible.
It really is. But also a little unnerving.
Of course.
I mean, what happens if something goes wrong?
That's a critical question.
Right.
And it's something that computer engineers are thinking about very carefully.
Okay.
Because it's not just about the technology,
Yeah.
it's about the ethical implications as well.
That's a good point.
We have to be responsible
Right.
with these incredible tools that we're creating.
This has been an amazing look at where we are
Yeah.
with computer engineering.
It's an exciting time.
It really is.
And we're just getting started.
I feel like my head's going to explode if we keep going at this pace.
Yeah, we've covered a lot of ground.
We really have.
But that's the thing about computer engineering.
Yeah.
It's constantly evolving. There's always something new to learn.
So for someone listening who's thinking, okay, this is really cool, I want to get involved.
Yeah.
What would you tell them?
I'd say if you're fascinated by technology,
Yeah.
if you love the idea of creating something new, computer engineering could be the perfect field for you.
Okay, so there are definitely career opportunities out there.
Oh, tons.
We hear about that all the time.
The demand for skilled engineers is enormous.
Okay, so it's not just hype.
No, not at all.
Okay.
Every industry relies on technology these days.
So we're not just talking about Silicon Valley.
No way, there are opportunities everywhere.
Like where?
Well, take healthcare, for example.
Okay.
Computer engineers are designing life-saving medical devices.
Wow.
They're using AI to analyze patient data
Okay.
to improve diagnoses and treatments.
That's amazing.
The automotive industry, too. They're the ones building the self-driving cars of the future.
Right.
Making vehicles safer and more efficient.
So many different options.
And those are just a couple of examples.
Yeah, it seems like computer engineering is a pretty good career path then.
It's a fantastic career path.
Okay, so what does a computer engineer actually do all day?
That's the beauty of it.
Yeah.
There's no one-size-fits-all answer.
Oh.
You could be designing microprocessors,
Okay.
developing software for the latest apps,
Right.
building secure networks.
Yeah.
You could even be working on quantum computers.
That's incredible.
The possibilities are truly endless.
So you could be working on the next generation of smartphones,
Exactly.
or life-saving technology, or even helping to build a more sustainable future.
It's all about using your skills to make a real impact on the world.
I love that.
And that's what makes this field so rewarding.
Okay, so for anyone feeling inspired right now, what advice would you give them?
Don't be afraid to dive in.
Okay.
Explore online resources. Experiment with coding tutorials.
Yeah. Don't be afraid to break things. That's how you learn.
And you don't need a fancy lab or anything, right?
Nope. All you need is a computer and a desire to learn.
And a lot of coffee.
Probably.
That's awesome.
Computer engineering is a field that rewards passion and perseverance.
So don't get discouraged.
Exactly. Embrace the challenge. Never stop learning. And who knows?
What?
Maybe one day we'll be talking about your groundbreaking work
I love it.
on this show.
That's all the time we have for today's deep dive, but wow.
It's been a journey.
It really has. From the abacus to AI, we've seen how far computer engineering has come.
And we've only just scratched the surface.
So to our listeners out there, keep exploring, keep questioning, keep pushing those boundaries.
And keep innovating.
That's right. Until next time, happy coding.